Number 31. How many times longer than the mean life of an extremely unstable atomic nucleus is the lifetime of a human? And they give us, now it says hint, right? They give us the lifetime of the unstable atomic nucleus, and it's on the order of 10 to the negative 22 seconds. Okay, so basically in this problem, what we're trying to do is we're trying to find a ratio. Okay, we're trying to find the ratio of the lifetime, I'll call it life of a human, to the lifetime of an unstable nucleus. Okay, now remember, in any ratio, especially if you're comparing two things to one another, it's best to compare apples to apples, meaning that the units must be consistent between these two. So it doesn't matter what unit you choose, meaning as far as time is concerned. You could have years compared to years. That's fine. You could have seconds compared to seconds. That's fine. But to do years per second, you could do that, but it would probably be better. It would probably be a little clearer if we were to choose the same units in both the numerator and the denominator, so we can get a true ratio of how many times longer one is than the other. So let's assume that the average lifetime of a human is 70 years. Okay, so already, right, I know I'm giving you a value in years, and they gave us the time value of the nucleus in terms of seconds. So I already know that I'm going to have to do a conversion. That doesn't matter which way you go, just choose one and work with it. So why don't we convert 70 years into seconds? So let's do that over here. So let's convert 70, I'll call it point. All right, I'll give it a decimal value. 70 years, and let's convert that into seconds. Okay, so let's write down what we're given. So 70 years. We're going to put years on the bottom, and then days on the top. Why? Because I do know this conversion, that there's 365 days in a year. There's really 365 and a quarter, but let's just keep it simple. Then I have to put days on the bottom so that they cancel. And now my next conversion would be to hours, because I know that there's 24 hours in a day. Then hours must go on the bottom so the units cancel. And now I can make the following logical leap, right? Because I know how many minutes there are in an hour. 60 minutes in an hour. And then last but not least, I do know the relationship between now seconds and minutes. 60 seconds in a minute. And now look, what's left, if you notice all the units have canceled, would be seconds. So once I do this calculation, I will find the number of seconds there are in 70 years. So 70 times 365 times 24 times 60 times 60 would be 2.2 times 10 raised to the, let's see, 9. 2.2 times 10 to the 9 seconds. So again, 2.2 billion seconds. It's a lot of seconds. Now, what we're going to do is we're going to now take this value, okay, that we just found, and this is essentially the numerator value here in my ratio, the lifetime of a human in seconds. And they now gave me the lifetime of the atomic nucleus in seconds, so what I can do is plug that in for the denominator. I'm going to do that on the bottom of the page. So now we're going to take 2.2 times 10 to the 9 seconds divided by 10 raised to the negative 22 seconds. So now let's do that division. So 2.2 raised to the 9 divided by 10 raised to the negative 22. And this works out to be some insane number, right? 2.2 times 10 to the 31. Right now it's unitless because the seconds have canceled. So what this tells me, but I can put this over 1, right? So what this tells me is that whatever time unit I use for the nucleus down here, it would be the equivalent time unit in the numerator for the human lifetime. So essentially, the human lifetime is 2.2 times 10 to the 31 times larger, okay, than the lifespan of an atomic nucleus. I've never been so happy to be human before. Thank you guys for tuning in. Hope this helped, and remember, please do subscribe. Until next time.